All right, let's go ahead and get going here. Welcome to the webinar, Large Scale Particle Simulation and Intelligent Computing, presented by Rocky DEM and Rescale, where we will see how engineering innovators leverage Rocky DEM and the Rescale platform to amp up the pace of the technological breakthroughs while driving down the cost of product development by modeling realistic materials and solving the resulting mathematical model on highly optimized supercomputer configurations in the cloud. It's a fancy mouthful. My name is Jolie Hales. I'm with Rescale, and I will be your moderator today. All right, next slide. We also wanted to make you aware of the Big Compute podcast, which is presented by Rescale, which shares stories about how engineers and scientists just like you are changing the world through simulations and supercomputing. We like to call you the undercover superheroes because you're doing big things that sometimes are behind the scenes. The podcast in particular was revamped a few months ago with a really high production value storytelling style, very similar to Radiolab, if you've heard that podcast. And recent episodes explore everything from simulations of tsunamis and how the data impact our coastlines to Mars rovers and an interview with Dan Stanzione of the TACC to the science behind COVID-19 and interviews with top scientists studying why the virus is so contagious and how ventilation systems affect the spread indoors, and which musical instruments are higher risk of spreading the virus, which pretty interesting which one was. The podcast is getting a lot of praise, so we invite you to take a listen anywhere you get your podcasts or on bigcompute.org. Now back to the webinar as we proceed. If you have any questions for any of our presenters that you hear today, feel free to write those questions in the questions window. And you should see that questions window on the right-hand side of the GoToWebinar interface. And then at the end of the webinar, we'll take a few minutes to answer those questions. So don't be shy. All right, and without further ado, let's go ahead and get started. So our first presenter for today is Vinicius Daros. Sorry, Vinicius, if I said your name terribly wrong. He is a mechanical engineer with a master's degree of science, or a Master of Science degree from the postgraduate program of Mechanical and Materials Engineering of the Federal University of Technology. And he currently works at ESSS as a CFD DEM applications engineer on the Rocky DEM technical team. So prior to joining ESSS, Vinicius was a researcher at the Center of Research on Rheology and Non-Newtonian Fluids, working on projects with the oil and gas industry regarding the transport of solids in turbulent flows. And then after Vinicius, we'll hear from Madhu Velakal, who is a solutions architect at Rescale. Based in Chicago, Madhu has a decade of experience in CFD and HPC systems. He has a Master of Engineering degree in Energy Systems from UIUC and a Master of Science in Mechanical Engineering from the University at Buffalo. Outside of work, he is an avid Arsenal FC fan, and at Rescale, Madhu enjoys enabling innovation and constructive disruption in simulation and HPC communities. You guys are both so fancy. At this time, I will go ahead and turn webinar control over to Vinicius to talk to us from Rocky.
Thank you, Jolie, for the nice introduction, by the way.
Yeah, no, it's my pleasure. Thanks for joining us. I'm going to make you presenter here, so let me know if that comes through, and then I will get off camera.
Okay, can you guys see the screen already?
Yep, looks good.
Okay, then. So thanks everyone for attending this webinar. And I'm here today to share a little bit with you about our high performance computing capability using Rocky DEM, which is one of the ESSS softwares. And today I'll be specifically focusing in that sense. So I'll showcase to you a few examples as well on how does Rocky DEM performs when you actually requires it to perform on real size industrial applications. Okay, so before I start, I would just like to give you a brief overview of the company itself. So ESSS is a Brazilian company. It's located, just a second, Julie, can you see my mouse cursor here?
I can.
I can? Okay, thank you.
Yeah.
So ESSS is a Brazilian company. It is based at Florianópolis, this city, which is in the south of Brazil. But we also have a bunch of other offices spread all across the world. As you can see here, we have currently 10 offices in 10 different countries. We operate in 10 different countries, and ESSS has been in the market for over 25 years now, and it is providing high quality solutions, both in the software perspective, but also as a service company providing consultancy projects for all of industrial segments. Okay, we currently have about 300 employees, and our main goal here is to reduce product development time, optimize processes, and improve product performance with high quality software solutions. Okay, these are a few examples of our clients. And you can see here that we actually supply a whole bunch of different industrial segments, from aerospace to mining and metal. And these are just some of our main clients that we attend here on ESSS. One of our main products, which is Rocky DEM, it's basically a high fidelity software, high fidelity particle simulation software, which provides you insight into granular flow, and Rocky can help you to solve problems or to tackle problems from tiny pharmaceutical tablets up to heavy mining equipment, if you want. And it kinds of it's highlighted from other competitors because it has some unique features such as particle shapes, breakage, multi-GPU processing, which is the focus of this talk today. Also, Rocky is fully integrated with ANSYS software. It can also deal with multi-body dynamics, and in our latest release, we have a fully customizable solution. So if you want to solve your own custom problem, you can do so by interacting directly with Rocky Solver. So moving on here, this is the basic outline of my presentation today. So I would like to start by discussing a little bit what is DEM, why Rocky is unique, and then we just move on to the Rocky GPU architected solver. I would like to show some CPU against GPU benchmarks that I have here today, and then I'll just move on to some conclusions. So for those who are not familiar with, DEM stands for discrete element method, and it's basically a numerical technique to study the behavior of both solid materials. So as you can see here in this first video, we have a barley conveying equipment from the agricultural industry. And you see that the barley particles, they are actually represented using its real shape. And we basically, what DEM is going to do is that it will solve the motion and track each individual particle here within your domain. And then you can have a lot of particle level information that are not easily accessible through regular experiments. And also, here I have another example. As you can see with both these animations, that Rocky, besides dealing with the particle motion itself, you can see a lot of clumps forming in here, which means we can deal with wet particles and sticky material. But you can also see here that we have a lot of complex motions taking place, and a lot of interactions of complex interactions between particles, and also between particles and the geometries. And this allows you to access a lot of valuable information, such as how is your equipment going to perform for a certain load of material? Is it going to wear too fast? Is it going to be durable for its whole plan life? And you can have all this kind of data by using Rocky. So Rocky current capabilities, and its main capabilities, as you can see here in this animation, is that we can basically treat any particle shape that you want to model. You can see here a lot of gummy bears, and then these other types of particles that have very complex shapes. And by doing that, we can definitely tackle the problems by accurately capturing the involved physics. And we can also deal with breakage, as I mentioned. I'm going to showcase a quick example later on. But you see here potato chips, bananas. You see like bottles falling over this pile as well. And besides that, again, Rocky is fully integrated with ANSYS tool. And one of its unique features is that to real industrial applications where you have large problems, Rocky has the multi-GPU processing capacity, which allows you to go way beyond traditional DM solvers. But does particle shape really matter after all? Well, I can definitely tell you that it does. As you can see here, we have glued spheres method to represent the same particle that you see here in the Rocky version. And you see that this is kind of a misrepresentation of the real particle, as you have all this bumpy surface. And as you see here, this is usually done in standard DM codes because spheres are way easier to track than complex shapes. For spheres, you just require basically to track the sphere center, the centroid of the sphere, and its radius, and you have everything. And you can detect contacts and so on. But for complex shapes like this one, you need to go way more complex than you do for this case. And this has some huge advantages when compared with these methods. For example, if you want like sharp edges, in this case, you will probably have to reduce this sphere size by a whole lot, and it will increase your computational cost by the same amount or even more, okay? And these surfaces causes like larger friction to be measured, and also when you decide to break on one of these particles, you will probably not conserve the particle mass because you need to recreate both fragments with another spheres. So of course that you lose some information by doing that. On the other side, Rocky can deal with all these features here on an accurate fashion. One of Rocky's features is also the ability to deal with flexible particles. And here I am showcasing to you an example of flexible fibers. So this is a tether machine, and the hay particles, as you can see, they are actually modeled as hay and not as a set of spheres. And so imagine that for these large aspect ratio particles, how many spheres would you require to model such particle? And in Rocky, we have a completely different way of modeling such particles, and the multi-GPU capacity allows you to run for this huge amount of particles here that will probably take you way longer to run on a standard CPU-based machine. Besides dealing with complex particle shapes, we can also break those particle shapes. We have Rocky deals quite well, quite nicely with breakage. For any kind of particle, we have breakage models for both standard particle shapes, but also for custom particle shapes. As this one you can see here, we are actually breaking these potato chips. And this is valuable for example, for the food industry, where they can actually see how much damage does their product suffer during its production. Moving on here, we can also combine everything like complex multi-body motions. We can do complex particle shapes, and we can do also breakage, all in the same problem with no extra difficulties. Rocky does everything for you. For example, here you have another equipment from the mining industry where you have this cone-shaped part, which is actually breaking the particles, as you can see here. And then we can measure the size of the fragments, the size distribution, and this will be available information for the mining industry. Of course, you can also see how is this component be worn out all over its lifetime, and this can also be used to improve the equipment design. And last but not least, I would like to show you that Rocky is also fully integrated with ANSYS. So this is a CFD coupled simulation of a tablet coating equipment using in the pharma industry. So you see here that this hot fluid, we are seeing temperature. The equipment is colored by temperature, as you can see in this color scale here. And you see that this hot fluid is actually exchanging energy with the particle bed, and you see it enters the system at 70 degrees Celsius, but it leaves at about 55 or 60 degrees Celsius, and it heats up the particles, and then it can dries the particle coating liquid that had been used in this problem specifically. Okay, and now the greatest part here is that Rocky is now completely customizable. So we have released with the latest official version the Solver API, which is basically a way of extending existing models, or you can also create new models. And the greatest part here is that you can access solver level data. You don't need to access only the data on an output level, but you can actually interact directly with the Rocky solver by creating what we call modules. And these are basically scripts that are coded in C++. And then as soon as you use Rocky's SDK or the development toolkit of Rocky, as soon as you compile the same code, it will work on both CPU and GPU. So Rocky will do all the hard work for you, and it will also be possible to compile those codes to run on both Windows and Linux platforms. And of course, these are all powered by NVIDIA graphic processing units. So in order to create some kind of context here to the scalability studies, I would like to show you how from a very general perspective, how does a DM calculation loop actually happen. So as you can see from this diagram here, as soon as the simulation starts, one of the first and main steps that we need to do is to actually, for each of the particles inside the domain, we need to populate a list of neighboring particles. And this is done in these, or also elements, of course, like the boundaries, as you can see here, represented by this wall. And as soon as we have a list of neighboring particles populated, then we just move on to Newton's second law of motion, and we calculate the resultant force acting on this particle, and then we can integrate the motion to obtain the next particle velocity and then the next particle position. And since this is based on Newton's second law, and we solve this kind of problem for each particle on a Lagrangian frame of reference, what happens is that for real industrial problems, this should be a very complicated problem to tackle, because you have like millions, maybe billions or trillions of particles here. And because of the way the DM method works, it can solve, as you can see here, it can integrate those equations of motion for each of the particles in your system independently. So by that I mean that every single particle inside your domain can be solved simultaneously. And this is completely different from continuous approach as we have for finite volume in the CFD side of things. But here for the DM codes, we can do it all at once. And this makes DM a very nice candidate for parallel processing, and not just for parallel processing, but for massive parallel processing. And in order to do that, of course, we need hardware resources. And we know that CPUs can be quite expensive. And Rocky developers have done the job for its users, and they have refactor the code entirely to be able to harvest the maximum capacity of GPU processing using NVIDIA CUDA programming language. And it used to have like a kind of limitation here, because we know that usually a GPU card has a limited memory, but then Rocky tackled this problem again, and it introduced the multi-GPU capability, and now you can have combined processing power, and then you can tackle way larger problems using multi-GPUs. And in order to showcase that, I finally move on to the first benchmark case that I want to show, that I want to share with you. And this one is basically a rotating drum, and we have here a lot of polyhedral particles. And by polyhedral, I mean that each particle is formed by 16 triangles, and we count 31,000 up to 2 million of these particles. So we have a lot of contact information to detect here in this problem. This is a complex problem. And of course that we use these hardware resources here to compare the performance. So we take 8 cores of this generation of CPU, and also we compare it with the NVIDIA Tesla V100 and also the latest NVIDIA A100 Tensor Core GPU. And for that we use 1, 2, and 4 GPU, one of each of these two mentioned models. And to do the comparison, we basically integrate this problem here for 20,000 solver iterations, which represents these 10 milliseconds. Okay, so in these two charts here, we have the blue bars representing 1 GPU, the orange bars representing 2 GPUs, and the gray bars representing 4 GPUs. On your left-hand side, you will see the polyhedral, the V100 card, and on your right-hand side, you will see the A100 performance. On the x-axis here, you see the number of particles divided by 8,000. So we go from 31,000 up to those 2 million I have mentioned. And here you see the relative speed up in comparison with those 8 CPU cores. So as you can see here, let's start with the V100. You see that for small particle counts, we actually degrade performance if we increase the number of GPUs. Okay, so 1 GPU is faster than 4 GPUs, and as we increase the problem size, we see that these scenario switches, and then we have the 4 GPUs starting to shine here, and then we have their top performance happening at about 500,000 particles. Okay, so we can see here that this for the V100, basically the top GPU performance is for about 125,000 particles per GPU. And of course that as soon as you top up, you start to overload the GPU, and you have and you kind of diminishes your performance again. But of course that this will probably flat out here at some plateau. And the main message here from this chart is not the actual GPU performance, but look at this chart here. Like if we have 4 V100s, we are talking about 80 times speed up. So let's imagine that increasing the number of CPU cores will scale performance like linearly. We would be talking about 640 GPU cores to give you the same performance of this case. Okay, so basically if you purchase 4 V100s, you have a very nice cluster, and this very nice cluster can mostly lie underneath your working desk. You don't need like a whole cluster infrastructure, a high performance computing infrastructure to tackle these kind of problems. And if we move on to the latest A100s, which are way better GPU than the V100s, we are going to move up this threshold further on. So you see here the GPU stopping up in performance at about 1 million particles now. And this means that basically or you can grow your problem larger using the A100, or you can solve it way faster using this better GPU card. If we compare here, only the blue bars are A100s and the orange bars are the V100s, you will see that usually the A100 performs better than the V100, and it gets more pronounced as we increase the problem size. In a general sense, you see that the A100, for the same number of graphic cards and a large particle count, the A100 can be 25% faster than the V100 card. In this other example here, as you see, we have a Reboom mixer case, and this is 30 million spheres in this case. We're not talking about shapes, but regular spheres. But even though these are spheres, you see that we have a lot of contacts in the bed here that need to be accounted for, and we also have a lot of complex interactions with the geometry. And for this case, we have used 2 NVIDIA Tesla V100, and then we have scaled up to also 2, 4, and 8 NVIDIA Tensor Core A100. And the results are here. You see that with the 2 V100s, we get about, we need about 1.5 days to solve 1 physical second of the simulation. And as we just switch the GPU card from V100s for 2 A100s, we already have a reduction in 25% of the total simulation time. And as we move on to 4 A100s, we get another 40% in comparison with the 2 A100, and another 30% if we increase to 8 GPU cards. And this is, in the end of the day, this is a reduction, like we are going from 1.5 days to only half a day to run this if we have available resources. And let's imagine that you want to run a problem that you want to solve this problem for 1 minute for 60 seconds. This will take you like 90 days to solve on 2 V100s, and this will take a third of that. Okay, so you could get your solution 2 months earlier using 8 A100. And then you can ask if this is okay, but A100s are expensive cards, but imagine the amount of time that you are saving here, the amount of engineer hours, the amount of computing time. You are not blocking the entire company machines to get your solution. And also that if you have a project and this project have a deadline, which is usually the case, you will have your solution way before with this hardware here than you will get with this one. And we are not even talking about the same comparison with CPUs, because CPUs will be will take you much longer to get you the proper results. So just to finish, I would like to mention that having this multi-GPU capacity enables you to go for the next level of physics simulation, so you can really tackle high fidelity problems. Okay, you can really go for your real scale problems using multi-GPU. And in the old days, GPU memory capacity was an issue, but Rocky has also tackled that by introducing the multi-GPU. So you can increase the number of GPU as far as your problem requires. And of course that you don't see this solution too oftenly in the market, because in order to harvest the full power of a GPU card, the code needs to be completely reprogrammed. And then ESSS has done that a long time ago, so that we have already done that. You just need to open the software and use it in its full capacity. And this is basically it. I would like to thank you all for your attention, and I think I'll just need to pass on to Madhu. Okay, thank you again.
Thank you so much, Vinicius. Appreciate it. I think you definitely had our attention, especially with those Pringles images. I'm not gonna lie.
Thank you.
So this time I'm gonna go ahead and turn over control to Madhu.
Okay, thanks, Jolie. Hello, everyone. Thanks for your time, and thanks for being here for the webinar. Vinicius, it was a really good presentation. I agree with Jolie. I was impressed with all the sprinkles and the bottom drops as well. So my name is Madhu Veldakal. I'm a solutions architect at Rescale. Today we'll be talking about what Rescale does and how we can actually run the exact simulation that you just saw on the Rescale platform. So if you're new, if you're not aware of about the company, just a bit of background what we do. So Rescale is a technology company that was founded in 2011 by two former Boeing engineers, right? So when they were working in Boeing, they understood the ability to fully utilize computational infrastructure to accelerate like HPC and product development and innovation. Right? So with this thought process, the company was founded, and since then we have grown to cater to 200 plus enterprise level customers all across the globe. Right? So our customer base is growing, and the markets we serve ranges from aerospace and public sector, and it's regularly growing on a daily basis. We are based out of San Francisco, but we do have global offices all across the world. We partner with different infrastructure providers, be it on-prem, hardware, cloud. That gives us the ability to run our platform and workloads across like 100 plus data centers throughout the entire globe. So what does Rescale do? So Rescale is a service provider which develops like a product, like a platform, which enables the scientists and researchers who will be running all those Rocky DEM simulations to have like a seamless experience. Right? So if you are used to running HPC systems or like used to running workloads on the on-prem cluster, so you know how the work experiences or like the workflow experiences. So what you see in the slide is the infrastructure layer that we talked about on the bottom. It could be either virtualized or hosted bare metal. It could be on-premise as well. And we also have the application layer on the top, which in case the Rocky DEM. Right? So there are three layers. The Rescale layer sits in between the application and the infrastructure layer, acting as like a control plane, which orchestrates the whole workflow. So the workloads that typically run on HPC systems can be automated based on your cost, budget, or the timing needs, and also it could be based on the business policies. Right? So if you are like a business executive or like department manager, if you're thinking, should I be prioritizing my engineers to run on like the latest and the greatest hardware, or should they be running on something which is more stable and cost and price performant as well? Right. So those questions can be answered with some policies on the Rescale platform. You can also balance between faster time to market versus like cost optimized solutions in terms of like hardware and infrastructure with the Rescale platform. So briefly touching on like the HPC stack or the whole ecosystem. So if you're used to managing or running on-prem or a HPC cluster, even something at a smaller scale, so you understand the complexity of it, right? So it could be categorized under different boxes. Some of them are defined here. So Rescale automates this whole different stack, HPC stack, to provide like a modern HPC experience. So we have like the infrastructure at the bottom, which is integrated by like a API approach, which is tied to the R&D workflow automation, where users are like admins or power users can create templates to be used across like the organization. So if you are in the IT operations or day-to-day management of things, you have the ability to set budgets, projects, and groups so that you understand how much is it being used and where it is being used. So security is all important because we are running with sensitive corporate level data on public infrastructure. So you have, as a security admin or a security leader, you have the ability to put like policy-based controls, so you know where the users are accessing from and what they are accessing for and things like that. So you have the granularity to orchestrate this on the platform. Related to that, the platform undergoes various strict audits and industry standard compliance process. As a result of that, the Rescale platform meets like a lot of industry standards like SOC 2, ITAR, FedRAMP, and things like that. Just moving one stack up, so we have the application and the license management control. On Rescale, as of today, there are like 600 plus applications with different versions pre-installed and ported to run seamlessly on any infrastructure that is available on the platform. With the ability to bring on like open source applications, standard ISVs or container-based workflows, you have the unparalleled flexibility to run your workload on the Rescale platform. Last but not least, so everybody understands data is the new oil. But only very few players like Rescale understands HPC data can be valuable as well, right? So if you're used to running like thousands of jobs on your prem, so what do you do with the data? Do you have insights on, are your engineers and researchers running on the optimized hardware? Is your job cost optimized? So with the ability to do like a full stack performance optimization, you have the insights which is not typically available on any other system. So you may be thinking, so why is it important? So why do I need like a modern HPC experience? What is so special, right? So just a bit background about digital transformation. As we moved along from the 60s to 2000s, the emergence of mainframe computers changed or transformed the data processing workflows, and also like the virtualization and the cloud computing providers have transformed the traditional business processes. Right? So these are some of the digital transformations that are celebrated across the whole industries. Right? So as of now, so it's almost like 80% of the business processes are running on the cloud infrastructure based on our internal survey. But when it comes to R&D computing, the digital transformation has been lacking, right? And there's a good reason why, because the needs for R&D computing are different than a standard commodity business process computing. You need like special hardware architectures, just like the way we saw. If you want to run like Rocky DEM, you need GPU architectures, which are like specialized accelerated hardware architectures. Even with GPUs, you could have like run on like V100s or A100s. So the needs are different. And also, like depending on the ISVs, the acceptance of cloud computing can be at a different level. So these have led to only 20% of adaptation of R&D computing on a R&D computing on a cloud infrastructure or any like public infrastructure. But the good news is, with the Rescale's R&D computing as a service, there is a solution, right? So with intelligent computing and some kind of automation based on hardware and software, you will be able to transform this R&D computing at an accelerated pace. So what does it look like? In a traditional computing approach, the users actually connect to an on-prem cluster. The process is very intuitive, like trial and error based or based on user experience. But with intelligent computing, it's all automated or on demand, and every single process has like a context. So the IT can look into budgets and hardware filters. The R&D can look into the hardware that they want. The business leaders can look into the utilization and economics of how the workflows are progressing on the platform. Just focusing on one aspect, with the full stack performance optimization, you have the ability to look into your jobs that are run on the platform, and you can optimize either for software, license costs, or hardware costs. So it can be also optimized for your business objectives as well. As a user, you may be thinking, so why is digital transformation important to me? So how does it actually affect the workflow or like my processes that I'm doing on-prem? So the on-prem, the job process or job assumption can be sequential, or it can be based on some policy constraints. With Rescale, your job is optimized for time, cost, and performance every single time. Right? So you get an unlimited infrastructure scale, so you can scale up. If you want to run on like 2 V100s, you have the flexibility to do it. If you want to scale it up, your model needs like more particles and more GPUs. You have the flexibility as well to run on like 4 or 8 V100s on the platform. And the other aspect is you can pick and choose the GPUs that you want depending on the model size. Right? So you don't want to run like a 200,000 particle model on an A100. That can be an overkill, right? So your architecture or your hardware is suited for your model, not the other way around. More specifically, so we are just looking at the 30 million particle that Vinicius showed us. And so in order to run this model on the platform, so we have the ability to run either on the V100s that I talked about, or also you can run it on the M60 GPU. So the flexibility and the choices that you have is enabled by the Rescale solution. So if you don't want to run on like different GPUs, all you want to run on like multiple GPUs of the same type, you have the flexibility as well. Right? So in this case, we are running on like 1 GPU all the way to 8 GPU. And Vinicius showed us, right, with running on multiple GPUs, you do see some performance gain in terms of like scalability, and with high fidelity models, you are getting a competitive advantage and more insights in your product development process that you may not be able to do it using your on-prem system or a system which is not flexible enough. With that, we can go onto the platform and see how we can submit this job on the Rescale platform. So this is a homepage. You should be able to sign up here. If you have credentials, you can log in using this page. Once you log in, this is the homepage where you see all the jobs that you ran before or some of the jobs that you're running right now. And we have other tabs on the top, which shows like desktops, files, and there are some other user profile settings that you can see on the Rescale platform. In order to submit a new job, just click on the new job tab here. So the job submission process is pretty simple on the Rescale platform. So it involves like 4 to 5 different steps. You select your input files. It could be either from cloud storage or from your computer. Once the input files are selected, you can select the software that you want to run on, the hardware, and if you have any post-processing scripts, you can select it there. If not, review the job settings, click submit. That just completes the job submission process. Let's go ahead and submit the job. I'm selecting my input files from the cloud storage. You have the option to select from your computer as well. You can also search files if you want from the cloud storage as well. Once the files are selected, click on Next, where you have the softwares that we have onboarded on the platform. The easiest ways to select the software is type in the name of the software in the search bar. So I'm selecting Rocky. On the software settings, typically there are 3 configurations that needs to be done. 1, the version that you want to run your job on has to be selected. As you can see, we have different versions of Rocky pre-installed on the platform. You change the name of the input file, and the commands that are required to run the software on the platform are preloaded. So all you have to come and change the input file, and then you should be ready to go. Next, the licensing option has to be configured. So if you have an existing license, we will be able to configure it in such a way that either the license stays on-prem or it can be hosted on the Rescale platform as well. Depending on the ISV, you have the option to purchase license from Rescale as well. In this case, I'm going to use my Rescale trial license. So I'm clicking on use on demand license. Select next. So now we are onto the hardware page. The infrastructure is categorized based on either it's a hardware with high interconnect or like more memory or higher clock speed. In this case, we'll be looking at the GPU hardware types. As shown before, so we have different GPUs that are available on the platform. I'm clicking on the Dolomite GPU type, which is like Broadwell CPUs and Tesla V100s. Here, you can select the number of GPUs that you want to run on. So the default is 1. You can click to increase it to 4 or 8. You can also increase the wall time that if you want the job for. Moving on to post-processing. So I don't have any post-processing scripts, and I'll move on to the review page. On the review page, just make sure that all the settings are configured well, and then if you're satisfied, you can go on to click submit. Once the job is submitted, it goes on to different steps. And when the job is running, you have the ability to look into the log files just to make sure that the simulation is progressing well, or if you like to stop this job and do some modifications for the input file. Once the simulation is done, all the files will be moved to the results page. When the job is running, it will be in the status page. On the platform, you have the ability to do post-processing and pre-processing using the desktops. The desktop job creation is similar to the job creation. You click on the new desktop. Select the software you want to run and the licensing and the hardware that you want to run on for post-processing. Once it's selected and launched, and once it's ready, you can connect to the desktop. Let me connect to a running desktop. Once it's ready, you can connect to a running desktop to do post-processing on the platform. The other aspect of the platform is the admin portals, right? So what we saw is the job submission. You can click on the admin portals on the left. There you can see some economics of how much it's being used on the platform by month. You can also look at some utilization for your organization as well. You have the ability to set policies on the platform where it could be a platform settings to say that these are the default wall times for my users. This is the you can also set up like hardware filter saying that this is the hardware my users have to run, or you can also restrict the software to any specific versions so that there is uniformity across the organization. You can invite members, create groups, and create projects. You can also assign like members to specific groups or projects depending on your business goals. You can also look at the financials of your organization. So you can get a monthly billing summary, either by organization or member or project. You can also set up like budgets on the platform. These are some of the project management tools that you can enable by using the Rescale platform. As part of the intelligent computing initiative, one thing that I like to show about is the performance dashboard. So what we are seeing here is the usage on the platform for almost a year. It is given by software, and it is also given by the hardware that those softwares are ran on. So what you can do is you can click on optimize on this page to get an optimized recommendation for this particular workload on the platform. So it does the optimizer takes care of the hardware costs and the licensing costs as well in order to come up with a recommendation engine for your workflow. Also, like when you're running, so if you have any issues, we have like a dedicated support team who should be able to help you with any issues, either with this help approach or like a live chat feature that we have on the platform. There is also like a documentation page where you will be able to look at like the basics of how to run jobs on the platform, some of the tutorials that we have, and also like some other resources that you, if you like to get more hands-on approach using the Rescale platform. With that, I'll come back to my presentation saying that, so Rescale is enabling intelligent computing for digital R&D. The way it does is like optimizes the whole HPC compute stack. It enables workflow automation. It helps with the R&D operations in terms of like budgets and projects and financials, and also helps with business management by providing policies or like security controls to make sure that your workload is optimized and safe and secure as well. With that, I would like to conclude my presentation and transfer to Julie.
Awesome. Thank you so much, Madhu. Appreciate it. Vinicius, you as well. If anybody has any questions for either one of them, now is the time to write those in the question window if you haven't already. It looks like we have a couple that trickled in. So I will go ahead and read those and any others that come in here. So first question, can Rescale be accessed from anywhere or is it geographically restricted? So that would be for you, Madhu.
Sure. Yep. We have users all across the globe. The platform can be accessed from anywhere in the world.
All right, cool. Easy answer. This one is from Jeff for Rocky ESS. How do you work with Rescale? What kind of collaboration do you use?
Well, what I can definitely say here is that Rescale has been helping us to direct our customers and also our channel partners to a better solution when they actually need to scale up their problems. So let's imagine that you have a certain hardware resource on your company, and then you need to increase this hardware resource for a specific project. So then we direct our customers to Rescale, and also our channel partners, they do the exact same, and they can use everything that Madhu has shared with us to pay for only what is necessary and for the time that is necessary as well. So you end up saving a lot of money. This is how we have been collaborating with Rescale on Rocky projects.
Great, thank you. Another question, this one is from Arpita. Do you have the NVIDIA A100 GPUs?
Great question. So we are in the process of getting A100s onto the platform. So if you're interested to run your workloads or have more questions about A100s, please drop us an email. And so I can say that, I've been working closely with the team. So our anticipated timeline is about a week or two to onboard A100s. So once we have this, so this is based on Rocky DEM's collaboration and the input that we got from them. So we have accelerated it for a customer use case. So if you have anything specific, please feel free to reach out to us. We will be able to accommodate that request.
Thank you, Madhu. A follow-up question on that. Can you run on multiple GPUs?
Yes, we can run on multiple GPUs, depending on the core type that you're selecting. So as we saw, we have the ability to run either 1, 4, or 8 GPUs.
Awesome. That is actually the last question. So if we don't have any others, it looks like we can give you all a few minutes back in your day. Thank you again to Vinicius and Madhu for presenting, and to all of you who have joined us today. And just a reminder that you can find information about any of our other upcoming webinars on our social channels. Also a reminder of the popular Big Compute podcast at bigcompute.org or wherever you get your podcasts. And a video recording of this, a link to that video recording will also be emailed out if you had questions about that and want to review some of the content that we shared today. So with that, thank you again for joining us. Have a great rest of your day and stay safe out there.